The rise of robotics in Industry 4.0. The rise of robotics in Industry 4.0 represents a profound transformation in the way industrial processes are designed, managed, and executed. Industry 4.0, a term that encapsulates the fourth industrial revolution, is centered on the convergence of digital technologies with physical production systems. Robotics plays a pivotal role in this evolution by integrating advanced sensors, artificial intelligence, and interconnected devices into the heart of modern manufacturing. In this new paradigm, robots are not merely isolated machines performing repetitive tasks. They are intelligent agents embedded within a vast network of cyber-physical systems that continuously gather, share, and analyze information to optimize the entire production process. At the core of Industry 4.0 is the concept of smart factories, where the integration of robotics with the Internet of Things, IoT, enables real-time monitoring and control over production lines. In these environments, robots are connected to digital networks and communicate with other devices, systems, and even human operators through seamless data exchanges. This connectivity transforms traditional factory floors into adaptive, self-regulating ecosystems where machines can sense, analyze, and react to changes instantaneously. Robots equipped with advanced sensors not only execute tasks with high precision but also collect data on variables such as temperature, vibration, and pressure, revealing insights that can lead to improved maintenance scheduling, reduced downtime, and enhanced product quality. Through this level of integration, robotics becomes a central element in achieving higher productivity and efficiency across various industrial sectors. The evolution of robotics within Industry 4.0 has been driven by significant advancements in both hardware and software. Over the years, robotic systems have become more capable as improvements in sensor technology, computing power, and machine learning algorithms have made it possible for robots to perform increasingly complex tasks. Modern robots are equipped with high-resolution cameras, LiDAR, ultrasonic sensors, and force sensors that enable them to perceive their environment in extraordinary detail. When combined with sophisticated control algorithms and AI-based decision-making systems, these sensory inputs allow robots to make precise adjustments in real time. Whether it is assembling small electronic components or welding large structural parts, the enhanced sensory and processing capabilities ensure that each task is carried out with unparalleled accuracy and speed. In addition to their increased sensory and decision-making capabilities, robots in Industry 4.0 are characterized by their flexibility and adaptability. Collaborative robots, often referred to as cobots, are designed to work safely alongside human workers without the need for extensive safety barriers. These robots are programmed not only to perform tasks autonomously but also to assist human operators in complex processes, learning from human demonstrations and adapting to dynamic workflows. This collaboration between humans and machines leverages the strengths of both parties. Robots provide precision and endurance, while humans contribute creativity, problem-solving, and emotional intelligence. The result is a synergistic work environment in which production becomes more agile and responsive to changing conditions and market demands. The influence of robotics on industrial operations extends well beyond the factory floor. In logistics and supply chain management, automated guided vehicles, AGVs, and autonomous mobile robots, AMRs, are dramatically transforming how materials are transported within warehouses, distribution centers, and production facilities. These systems navigate complex environments with minimal human intervention, reducing the risk of accidents and optimizing routing to save time and energy. By automating material handling, companies can reduce operational costs and meet the increasing demand for rapid shipping in today's e-commerce-driven market. Furthermore, these mobile robotic systems are often integrated with warehouse management software and inventory control systems that provide real-time data on production status, location, and product availability, fostering a more responsive and efficient supply chain. Beyond traditional manufacturing and logistics, robotics in Industry 4.0 is also making its mark in maintenance and quality control. Predictive maintenance, powered by data analytics and sensor inputs from robotic systems, allows early detection of equipment failures before they occur. By continuously monitoring critical components, robots can identify anomalies and schedule maintenance activities proactively, thus minimizing unexpected breakdowns and extending the lifespan of machinery. In quality control, high-precision robotic vision systems inspect products at various stages of production. These systems can detect minute defects and deviations that might be missed by human inspectors, leading to higher quality standards and reduced waste. As a result, companies benefit from more consistent output, improved customer satisfaction, and stronger market competitiveness. Another significant aspect of robotics in Industry 4.0 is the integration of digital twins, virtual representations of physical assets that replicate the behavior and performance of their real-world counterparts. Digital twins enable companies to simulate and optimize production processes in a risk-free environment. Robots provide real-time data to these digital models, allowing engineers and managers to explore various scenarios, predict potential issues, and implement strategic improvements without disrupting actual operations. This synergy between physical systems and their digital replicas creates an iterative feedback loop that continuously refines operational efficiency and reliability. Through digital twins, robotics not only enhances current processes but also provides a platform for future innovations in production technology. The economic impact of robotics in Industry 4.0 is substantial. By automating routine and labor-intensive tasks, companies can significantly reduce production costs and increase output. The enhanced efficiency of robotic systems leads to shorter production cycles, lower error rates, and reduced waste, all of which contribute to higher profit margins. Moreover, as technological advancements continue to drive down the cost of robotic systems, smaller and medium-sized enterprises are finding it increasingly feasible to adopt automated solutions. This democratization of advanced manufacturing technology fosters a more competitive business environment and drives economic growth across multiple sectors. The transition to widespread robotics adoption in Industry 4.0 does, however, bring challenges that must be addressed. One of the foremost concerns is the potential displacement of human workers, particularly in roles that involve repetitive or manual tasks. While robotics offers significant productivity benefits, companies and governments must also invest in retraining and upskilling programs to help the workforce transition into new roles that require more complex, cognitive skills. The shift toward automation necessitates a rethinking of traditional workforce models, with an emphasis on collaboration between humans and robots rather than complete replacement. Ensuring that the benefits of increased productivity are shared broadly and that workers are equipped with the skills needed for the evolving job market is an essential challenge that accompanies technological progress. Privacy and cybersecurity also emerge as critical issues amid the growing integration of robotics with digital networks. As robots become more interconnected and reliant on cloud-based platforms to operate, they are vulnerable to cyber attacks that could disrupt production processes, steal sensitive data, or cause physical harm. Companies must invest in robust cybersecurity measures that safeguard their robotic systems and the data they generate. This includes employing encryption protocols, regular system audits, and proactive threat detection strategies to protect against vulnerabilities. As cyber threats become more sophisticated, a continued emphasis on security will be crucial in maintaining the integrity and reliability of interconnected industrial systems. The future of robotics in Industry 4.0 is filled with promise and potential. Ongoing advances in artificial intelligence, sensor technologies, and network connectivity will continue to push the boundaries of what robotic systems can achieve. The development of agile and self-optimizing robots that can operate seamlessly in dynamic, unstructured environments is no longer a distant goal. It is an emerging reality that signals the next frontier in industrial automation. As these innovations mature, we can expect robots to assume more complex responsibilities, from intricate assembly processes to entirely autonomous production lines that require minimal human intervention. Moreover, the convergence of robotics with emerging technologies such as augmented reality, virtual reality, and 5G connectivity will further accelerate the integration of digital and physical systems in industrial settings. Enhanced connectivity will allow robots to operate in real time, sharing data quickly and effectively across vast networks. This level of integration will lead to smarter production lines that are capable of adapting on the fly to market changes, supply chain fluctuations, or operational disturbances, thereby ensuring resilience and sustained performance. In summary, the rise of robotics in Industry 4.0 marks a pivotal moment in the evolution of industrial production and automation. The integration of intelligent robotic systems with real-time data analytics, robust connectivity, and advanced control mechanisms is transforming traditional manufacturing, logistics, and maintenance operations, creating a highly responsive and efficient industrial ecosystem. While challenges such as workforce displacement and cybersecurity must be carefully managed, the benefits of increased productivity, cost savings, and enhanced product quality offer compelling reasons for the continued adoption of robotics. As ongoing technological advances further blur the lines between physical and digital systems, robotics will remain at the forefront of innovation, driving the evolution of smart factories and redefining the future of industry.